Hey there, amazing friends. I warmly invite you to join me on this exciting journey by subscribing to my channel, liking, commenting, and sharing my videos. Every like, comment, and share brings us closer together and fuels my passion to create more great content. Your support truly makes all the difference. Thank you for being the heart of this community. When light bends backwards, the untold stories of scientists who glimpsed a past universe. In the summer of 1987, deep in the bowels of a long-forgotten observatory perched on the edge of a windswept plateau, a group of scientists gathered under a sky fretted with stars. Their task was as routine as it was ambitious: to observe distant galaxies and capture the subtle curvature of light as it journeyed across the cosmos. Yet on one seemingly ordinary night, as the cooling air of the desert whispered through the open dome, something inexplicable occurred. Dr. Elena Marquez, an astrophysicist with a fierce determination and a reputation for challenging conventional wisdom, was the first to notice that the starlight appearing in the telescope's eyepiece did not behave as expected. Instead of following the predicted paths dictated by Einstein's general theory of relativity, a faint, almost imperceptible reversal shimmered along the edge of the observed field, a subtle bending of light that suggested not merely gravitational lensing, but a phenomenon that defied the linear progression of time itself. Elena's heart pounded as she rechecked her instruments, recalibrated the sensor arrays, and exchanged hurried glances with her colleagues. The readings were consistent, repeating over several successive exposures. Light was bending in a direction opposite to what theory predicted, as if some portion of the electromagnetic spectrum was traveling backwards, carrying with it a ghostly image of a universe that had long since passed into memory. What she and her team had inadvertently captured was a glimpse, a fleeting window into a past universe, a moment frozen in time and then thrust back into the present through a cosmic quirk. In the following days, the observatory became a crucible of feverish debate and cautious excitement. Dr. Marquez and her team pored over data, comparing their results with historical astronomical records and re-examining established theories. Their instruments, normally reliable and precise, confirmed the anomaly. The phenomenon was not a mere instrument glitch. It was as if the fabric of spacetime had momentarily folded onto itself. The team began referring to the event simply as the reverse light phenomenon, and word soon spread beyond the observatory's walls. At conferences and in academic journals, whispers of their discovery sparked both intrigue and skepticism. Some colleagues posited that what they had seen might be a rare type of gravitational mirage, a lensing effect caused by an unseen massive object between Earth and a distant galaxy. But as the weeks passed, the data resisted all conventional explanations. The pattern of the reversed light was inconsistent with any known distribution of dark matter or interstellar gas. Instead, it resembled a static snapshot, as if the light had been captured from an era that no longer existed. As the news began to circulate in hushed tones through the scientific community, a motley coalition of researchers from diverse fields started to take an interest. The anomaly attracted not only astrophysicists, but also theoretical physicists, cosmologists, and even historians of science. Dr. Marcus Lee, a theoretical physicist known for his work on quantum gravity, arrived at the observatory to examine the data. Marcus had long speculated that the nature of time might be far more malleable than mainstream physics admitted. Over coffee in a cramped break room, he confided to Elena that for years he had entertained the possibility of temporal echoes, residual signals from a past cosmic state that might occasionally bleed into our present, especially in regions of intense gravitational distortion. He argued that if such temporal echoes existed, they might be detected as slight aberrations in the propagation of light. Elena, her eyes alight with a mix of scientific curiosity and something akin to wonder, nodded slowly. "It's as if we're looking into the rearview mirror of the universe," she murmured. "A glimpse of what once was," Now, coming back to us. The implications of such a phenomenon were staggering. If light could, under certain circumstances, bend backwards and deliver an image from the past, then in theory, the cosmos might be capable of storing a kind of historical record, a visual archive of epochs long gone, encoded in the very fabric of spacetime. The idea soon took root among the gathered minds. Over the next few months, the team at the observatory embarked on a series of experiments designed to replicate the phenomenon. They adjusted their telescopes to target specific regions of the sky where conditions might favor such temporal reversals, areas near supermassive black holes, nebulae with turbulent magnetic fields, and regions known for their dense clusters of ancient stars. They painstakingly calibrated their instruments, introduced control measures to rule out human error, and even invited external experts to verify their procedures. In one experiment, while focusing on a particularly old and dim galaxy cluster, the sensors recorded not only the expected redshift but a second set of images, fainter, with a sepia tone quality, as if seen through a layer of dust and age. The pattern was unmistakable. The primary image depicted the galaxy cluster in its current state, but the secondary image showed structures that were more diffuse, more ancient, as if they belonged to a universe that had long since evolved past that point. The discovery sent ripples through the scientific community. Theoretical papers were drafted overnight, and soon symposiums were convened in prestigious halls where scientists debated the implications. Was this a natural archival process of the cosmos? Could these temporal remnants offer clues to the origins of the universe, to the transition from the primordial chaos of the Big Bang to the ordered cosmos we see today? Or were they a product of exotic physics, perhaps a hint at dimensions beyond the familiar four? Among those captivated by the mystery was Professor Amelia Roth, an eminent cosmologist from a leading European university. Amelia had dedicated her life to unraveling the early history of the universe and was known for her incisive insights into cosmic inflation and dark energy. When she visited the observatory, she spent hours poring over the data, her face inscrutable behind a pair of thick spectacles. What we're seeing, she explained during a closed-door session with the team, could represent a remnant of a phase transition in the early universe, an echo of the inflationary period that, under certain extreme conditions, managed to reverse the normal flow of time's arrow. Imagine a cosmic tape recorder that occasionally plays back a snippet of its own history. Her words, though couched in theoretical language, resonated deeply with the innate human desire to witness the origins of everything. Yet for every hypothesis Amelia offered, there emerged counterarguments. Some skeptics insisted that the phenomenon might simply be an interplay of light with unusual magnetic fields, or a misinterpretation of overlapping signals from multiple sources. But as more independent teams reported similar anomalies from different observatories around the world, the weight of evidence began to tilt in favor of the extraordinary claim. News outlets caught wind of the debate, and soon headlines began to surface. Scientists witnessed glimpse of past universe. Light bends backwards, a cosmic time capsule, while most mainstream media treated the story as a tantalizing mystery rather than proven fact. It ignited public imagination. Television segments and magazine articles compared the discovery to looking into a time machine, with scientists describing it in metaphors of peering through the rearview mirror of time or catching a glimpse of the universe's baby pictures. Documentaries were planned, and interviews with the leading researchers were broadcast, fueling both wonder and skepticism among viewers. The phenomenon, dubbed by some as temporal reflection, took on a life of its own in the public sphere, merging scientific inquiry with elements of myth and speculative fiction. As the fervor grew, a new generation of researchers emerged, eager to build on the original discovery. Among them was a young postdoctoral fellow named Ravi Kumar, whose enthusiasm was matched only by his meticulous approach to experimental design. Ravi believed that the key to understanding the reverse light phenomenon lay in capturing more detailed spectral data, information that could reveal the precise wavelengths and intensities of the temporal echo. Over the course of a grueling year, Ravi designed a series of custom spectrometers and collaborated with engineers to upgrade the observatory's imaging systems. Late nights in the lab were spent calibrating devices, analyzing terabytes of data, and cross-referencing results with simulations of cosmic evolution. Slowly, a pattern emerged. In the secondary images captured during temporal reversals, certain spectral lines associated with elements forged in the first stars appeared with a slight shift that indicated not just age, but a temporal offset of several 100 million years. Ravi's findings suggested that the secondary image was not a random blur, but a coherent snapshot of the universe at a very different epoch, one that modern cosmology had long since moved past. The implications were profound. If verified, this could mean that the universe, under the right conditions, might reveal its own history in reverse, a process that might allow scientists to study events that occurred long before the formation of galaxies, perhaps even to glimpse the era of cosmic inflation. Ravi's work, published in a series of technical papers, attracted both accolades and intense scrutiny. Peer reviewers marveled at the ingenuity of the experimental setup, but remained cautious, pointing out that extraordinary claims required extraordinary evidence. Meanwhile, debates raged on at international conferences. At a symposium in Geneva, heated discussions unfolded between proponents of the temporal echo hypothesis and those who argued for more conventional explanations. One prominent critic, Dr. Samuel Porter from MIT, argued that atmospheric interference or unexpected instrumental noise might account for the peculiarities in the data. He pointed to known phenomena in ground-based astronomy where light can sometimes refract in unpredictable ways due to temperature gradients or humidity fluctuations. But when Dr. Porter's team attempted to replicate the conditions using controlled laboratory setups, they failed to produce the same reverse signals. The anomaly persisted only when observing specific deep space objects under the unique conditions present at the observatory's high-altitude location. Dr. Porter conceded that while the evidence was not yet definitive, the repeated occurrence of the effect across different instruments and observatories made it a phenomenon worthy of further investigation. Over time, the investigation of reverse light grew into an interdisciplinary quest, merging astrophysics, quantum theory, and even philosophy. Discussions began to explore the nature of time itself, whether it was an emergent property of the universe or a fundamental dimension that could be manipulated. Some theorists posited that if light could momentarily bend backwards, it might be possible, under extreme conditions, for information from the past to be transmitted to the present. This idea sparked both excitement and existential dread. Could it be that the universe was, in some secret fashion, recording its own history and allowing select moments of the past to reappear? Such a notion touched on the age-old human desire to witness history firsthand, to see the lost epochs of cosmic creation, even if only in fleeting glimpses. As the scientific community grappled with these ideas, public interest reached fever pitch. Documentaries, popular science magazines, and late-night talk shows ran segments on the backwards light mystery, each adding layers of speculation. Some suggested that this phenomenon might even open the door to time travel, though most researchers dismissed that as an overly fanciful extrapolation. Instead, the focus remained on understanding the limits of our current models and exploring whether this anomaly hinted at physics beyond what was known. In academic circles, spirited debates unfolded in the pages of journals and at conferences, with some young researchers daring to propose that the phenomenon might be explained by interactions between dark matter and ordinary matter, or by fluctuations in the fabric of spacetime at quantum scales. Others speculated that what they were witnessing could be the residual glow of an earlier cosmic phase, an echo of the universe's infancy that had been stored in the interstellar medium only to be released under the right gravitational conditions. These ideas, while bold, were not entirely out of step with modern cosmological theories that acknowledged the universe's early state was far more chaotic than the serene cosmos we observe today. In the midst of these debates, personal stories began to surface from the scientists who had been part of the original discovery. Dr. Marquez, whose initial observations had sparked the global interest, often spoke of the moment she first saw the reverse light as if it were a vision. "I remember feeling as though I had been given a brief, ineffable glimpse of something vast and timeless," she recalled in an interview. "It was like looking into a mirror that reflected not what is, but what once was, a universe that had already died, yet whose memories still lingered." Her voice, measured and thoughtful, resonated with both awe and melancholy. Other scientists described similar experiences, a sense of being overwhelmed by the enormity of the cosmos, or feeling as though they had momentarily stepped outside the usual flow of time. These testimonies, while subjective, lent a human dimension to the phenomenon, reminding everyone that science is not just about equations and instruments, but about the moments of profound wonder that can change one's life forever. Among the most memorable personal accounts was that of a young postdoctoral researcher, Ravi Kumar, whose tireless work in deciphering the spectral signatures of the reverse light not only advanced the technical understanding, but also transformed his view of the universe. "It was as if I were reading the diary of creation itself," Ravi once confided to a small group of colleagues in a quiet corner of a conference hall. "Every photon carried with it a memory of the past, a whisper of events that shaped everything we see today." In that moment, the idea of time as a one-way arrow melted away, replaced by a more fluid, almost cyclical notion of existence. Ravi's words captured the imagination of many, inspiring a new wave of research that sought to bridge the gap between observational astronomy and speculative theory. His work, though still met with skepticism by some, has become a cornerstone of the ongoing inquiry into temporal anomalies, a field that now teeters on the edge of what we call science and what we dare to imagine. In laboratories and observatories around the world, teams attempted to replicate the reverse light phenomenon under controlled conditions. Some experiments were conducted in deep underground facilities, shielded from atmospheric noise, while others took place in high-altitude regions similar to the original observatory's location. Despite the diversity of methods, the effect remained stubbornly elusive, a fleeting, almost ethereal signal that defied easy categorization. Advanced computer simulations were run to model the behavior of light under extreme gravitational and quantum conditions. The results hinted at the possibility that under very specific, rare circumstances, the normal progression of time might momentarily bend for photons traveling through regions of intense energy fluctuations. Though these simulations were far from conclusive, they provided a tantalizing glimpse into a realm of physics that few had dared to explore, a realm where the past and present might briefly merge in a dance of light and shadow. Beyond the technical details and theoretical debates, the reverse light phenomenon ignited a broader cultural conversation about the nature of time and memory. Writers, filmmakers, and artists began to draw inspiration from the idea that the universe might carry echoes of its own history, that by observing the cosmos, we might be privy to secrets of a bygone era. Science fiction novels emerged, featuring protagonists who discovered that the cosmos was not a static backdrop, but a dynamic archive of its own evolution. Documentaries and television programs, while often sensationalized, spurred public interest in topics that had once been confined to dusty academic journals. The story of the scientists who had witnessed light bending backwards became a metaphor for the human quest for understanding, a reminder that the universe is full of mysteries waiting to be unraveled, even if the clues are as ephemeral as a reversed photon. As years turned into decades, the legacy of that fateful night in 1987 persisted. The observatory where the discovery was made underwent renovations and technological upgrades, yet the reverse light phenomenon was never observed with the same clarity again. Some researchers speculated that the conditions required for the effect were so precise that they might occur only once in a millennium, or that a subtle change in the cosmic environment had temporarily closed that window into the past. Others believed that the original signal had been a once-in-a-lifetime glimpse of a cosmic memory, a chance occurrence that reminded us of the universe's boundless capacity for surprise. Despite the absence of repeated observations, the impact of that discovery continued to resonate in academic circles, influencing theories of cosmic evolution and time's elusive nature. In the twilight years following the initial discovery, the scientists involved often met at symposiums and informal gatherings, sharing personal recollections of that extraordinary night. They spoke of the moment with a mix of scientific rigor and poetic awe, of how, in that fleeting instant, the rigid laws of physics seemed to soften, allowing them to peer into a universe that existed in a state both alien and achingly familiar. Dr. Marquez recalled lying awake in her hotel room after the observation, listening to the hum of the cooling air and imagining the cosmic tapestry that had unfolded before her eyes. Ravi Kumar, now a respected professor, still felt a shiver when he remembered the spectral quality of the secondary images, the sepia tones of a universe long past, hinting at civilizations and cosmic events that modern eyes could scarcely comprehend. Their stories, though grounded in the technical details of instrumentation and spectral analysis, carried an unmistakable emotional weight, a shared experience that transcended the boundaries of conventional science and touched upon something profoundly human: the desire to understand our origins, to glimpse the deep past, and to connect with the mysterious forces that have shaped our existence. Public fascination with the reverse light phenomenon continued to grow, even as official observations remained sporadic. Documentaries chronicled the journey of those early scientists, blending archival footage with modern interpretations of their data. Museums held special exhibits dedicated to cosmic anomalies, where a replica of the original instrument setup was displayed alongside computer simulations of the phenomenon. Visitors marveled at the idea that light could, under certain conditions, carry with it the memory of a universe that had already faded into history. The exhibit's centerpiece, a large, interactive screen showing an artist's rendering of the reversed light effect, became a popular attraction, sparking questions and debates among audiences from all walks of life. Yet for all the public wonder, the reverse light phenomenon also carried a note of melancholy, a reminder that even the universe is not static, but a dynamic, ever-changing tapestry where the past is never truly gone. In quiet moments, scientists mused about the possibility that our current observations were but one layer in an infinite hierarchy of time, a reality where every moment leaves behind a ghostly echo that can, under the right conditions, be seen once again. They speculated that perhaps, in the far future, advanced civilizations might harness this effect, using reversed light as a means to peer back into their own history, to recover lost knowledge, or even to correct past mistakes. The implications were both uplifting and daunting. On one hand, the phenomenon hinted at a universe rich with hidden memory, a cosmic repository of all that had ever occurred. On the other hand, it underscored the fragility of our present moment, a reminder that the flow of time, as constant as it seems, might have cracks through which the past can leak. In the years that followed, the legacy of that discovery continued to influence scientific thought and public imagination alike. The original observatory, now upgraded with state-of-the-art technology, became a pilgrimage site for those who believed in the mysteries of time. Scholars from around the world published papers that referenced the reverse light phenomenon as a stepping stone toward a deeper theory of quantum gravity and cosmic memory. At international conferences, debates raged on about the nature of time, whether it was an arrow pointing inexorably forward or a more fluid dimension capable of folding back on itself. Some researchers even proposed experimental setups to deliberately induce similar effects using controlled gravitational fields, while others focused on the philosophical implications. If we could see into the past, what responsibility would we have to alter our present? Such questions were not merely academic. They touched on the deepest recesses of human curiosity and the eternal quest for meaning. For the scientists who had borne witness to that singular night, the experience remained a touchstone, a moment when the known laws of nature bowed to the vast, mysterious possibilities of the cosmos. They continued their research with a blend of cautious optimism and profound humility, aware that their discovery was only a fleeting glimpse of a truth that might be forever beyond complete understanding. Dr. Marquez often reflected on that night in quiet moments, recalling the sensation of time bending backwards as if it were a river momentarily flowing in reverse, carrying with it echoes of a distant past. Ravi Kumar, now teaching a graduate course on cosmology, would occasionally show his students a still image from that night, a spectral sepia-toned galaxy whose features, though blurry, evoked an era lost to time. His lectures, interwoven with personal anecdotes and theoretical insights, reminded his students that science was not just a collection of facts, but a profound, often emotional journey into the unknown. And so, as the decades passed and the mystery of the reverse light phenomenon remained unsolved, its legacy continued to shape the way we think about time and memory. The notion that the universe might store a visual archive of its own history resonated deeply with those who yearned to understand where we came from and what forces governed our evolution. It became a metaphor for the resilience of memory, a reminder that the past, no matter how far it recedes, leaves an indelible mark on the present. The phenomenon, elusive as it was, symbolized the eternal interplay between order and chaos, between the predictable flow of time and the unexpected moments when the universe reveals its hidden depths. In the end, when light bends backwards, the untold stories of scientists who glimpsed a past universe is not merely a chronicle of an anomalous signal or a scientific puzzle. It is a celebration of human curiosity and the relentless drive to uncover the secrets of existence. It is a tale of scientists who dared to challenge the known, who peered into the cosmic mirror and saw not just stars and galaxies, but echoes of a bygone era, a universe that had already lived its story, only to have its narrative briefly replayed in a cascade of bending light. And even though the phenomenon has since grown quieter, its impact lingers in the hearts of those who witnessed it, in the theories that continue to be debated, and in the unyielding sense that the universe still holds mysteries beyond our wildest imaginings. For every observer who has ever stared up at the night sky and wondered about the passage of time, the reverse light phenomenon offers a tantalizing possibility that the cosmos is not a linear progression from past to present, but a dynamic, multidimensional tapestry where time can, on rare occasions, loop back on itself. And in that possibility lies the promise of discovery, the spark of insight that reminds us that the journey of science is never complete. It is an endless quest to piece together the fragments of a vast, unfathomable puzzle, one where every photon might carry a story, every glimmer a secret, and every bending of light might be the universe's whispered recollection of its own glorious past. Thus, even as the mystery remains unsolved and the signal has long since faded into the background hum of the cosmos, the memory of that night, of that impossible reversal of light, endures as a beacon of hope and wonder, a testament to the idea that the past is never truly gone, and that if we are brave enough to look, we might just glimpse the echoes of a universe that once was, waiting to be understood again.